Absolutely. Hey, DC. Good morning. Good morning. I'm just glad you're here. No worries. We just got started. Yes. Yes, yes, yes. It is 50 joules. Thank you, Pamela. Hello, hello, by the by. Glad you're here. Yeah, 50 joules of work is being done on this box. Now, answer me this, okay? For work to happen, force needs to move in. How does that need to be related to the direction of the movement? Okay. How do they need to be related? Okay. Are they perpendicular? Are they parallel? I think I'm going to sneeze, so excuse me. Nope. As soon as I turned off my mic, it went away. Okay. So, hello, Jennifer. So glad you're here. Hello, hello. So, what's the direction of the force and the direction of the movement? How are they related? Are they parallel or are they perpendicular? What do you guys think? Yeah, thank you. Yes, they are parallel. Good job. Thank you so much. Okay. Hello, Christina. Glad you're here. Emily. Hello. Hello, Errol. So glad you're here. Hello, Francisco. Who else? Gwen. Hello. Hello. Praise Lynn. Hello. Hello. How are you? Hey, Rylan. Hey, Sabrina. Sophia. So glad you guys are here. Awesome. Okay. So, as always, our norms and expectations, please don't share any personal information. Remember to keep your behavior, language, and webcam school appropriate at all times. Know that this will be recorded for learning purposes, and I really appreciate your participation. It just makes the class so much better. So, today is the last day of September and it is the week 7. Our progress reports are going home this week. Grades have been closed. Last time to turn in any submissions was at noon today. So we are going to finish our Unit 3 this week and then begin Unit 4 on Friday. Now, our Unit 3 exam is due on Thursday. And guys, I want you to know that I've been writing commentary on your exams. If you get a math problem wrong, I write in the box to let you know what you've missed. And give you hints about maybe how you can fix it, okay? So then I found out on Friday that a lot of you don't know how to go back and look at this feedback, okay? So I've been writing a lot of stuff that you haven't been reading and maybe haven't even known it was there. So if you get your test back, okay, and you don't like the grade that you have, I want you to make sure that you go into I've written, okay? So what you want to do, dang, the marker has a mind of its own. So what you want to do is on OHS, go in and on your toolbar up at the top, click on the progress toolbar. Then scroll down, and on the left side, you're going to see where it says quizzes. Okay. And then find the quiz that you want to take or that you want to look at, and click on the attempt. And then it'll open it up. It'll show you your work, and it'll show you any comments that I left you. Okay. So also, I've also found out that on the grade tab, you can see part of my comments. You can't see all of them. This is the best way to see my comments. So just so you know, go here and look and see if I've left you hints, so you can redo that assignment and get a better grade. Okay. Okay. So with that, we are going to talk about power today. Okay. And how power is related to energy and work. Again, our Unit 3 exam is due on Thursday. So I have just dropped the notes in the chat box. Go ahead, open those up, give me a thumbs up, let me know that you are ready to go. Okay, today we're going to be talking about work and power, how it's related, and how they're different. Thank you, Tatiana. Thank you, Yosef. Thank you, Jennifer and Jenna, Kura, Najina, Pamela. Thank you, Grace and Gwen, Pacifico, Errol, Brittany, Angelica, and Talia. Thank you. I appreciate you guys so much. Awesome. Thank you, Christina. Awesome. Okay, so tell me in the chat box, who do you think is more impressive? We've got two runners. They're running a 400-meter. They're going around the track for 400 meters. Person A runs the distance in 1:13. Person B walks the distance in 5:42. What do you think? Who is more impressive? Yeah, for sure. The person who's running, person A, right? They're a lot more impressive because they did it in a faster time. They both ended up in the exact same place, but person A did it in a lot faster time. And that is power. Okay, that is power. Power is how fast you do it. Okay, remember, energy is what the ability to do work, right? Work is how I change the energy to do whatever I need to get done. Power is how fast I do it. Okay. Now, it's really important to remember that it's power, how fast I do something, doesn't change the amount of work that I'm doing. Person A ran 400 meters. Okay. Person B walked 400 meters. Both of them did this same amount of work, just person A did it a lot faster. Okay. So question number 2, work stays the same, but more power speeds up the process, whatever it is, whether it's going around a track for 400 meters, it's lifting weights or whatever. Okay. So that's the answer to question number 2. Question number 2. Okay. Now, power, the formula for power is work over time, work divided by time. Okay. Notice that The symbol for power is a capital P. Woohoo! And it's work over time. Now, here is something that can goof us up. Notice that the units for power is watts, and the symbol for a watt is a W, which is the same symbol that is for work, right? So if you ever see a number in front of a capital W, you know that it is our unit for watts, okay? If you see a W just hanging out, then we're talking about work, okay? Make sense? You guys good? Yeah? Awesome. Thank you. Thank you, thank you, thank you. Okay, perfect. So we're going to close this out. We're going to go to the next one, and you guys have the opportunity to match the term with the definition. Okay, so grab a pen, grab a marker, grab a highlighter. Don't let it run away from you. Exactly. Yes, yes, yes. I love all the colors. Perfect. So energy is the ability to do work. Work is the change in energy, what you do. And then power is how fast you do it, right? It is work over time, work over time. And when I say over time, that means I'm dividing, right? So give me a thumbs up. Let me know. Are you good with this question? Yeah, thank you, Julia. Thank you, Errol. Thank you, Pacifico. Thank you, Kura and Maddie, Jenna. Thank you, Najina. Thank you, Yosef and Sabrina. Awesome. Perfect. Okay, so here we've got two bikers, okay? Both of them are going up the same hill, okay? That means that the distance up this hill is the same. This also means that the force they need to pedal up the hill is the same, okay? But biker A did it in 30 seconds, whereas biker B did it in 45 seconds, okay? Sorry, Antoine. Do you need me to go back? Yes? Go back. I will go back. My bad. I'm sorry, sorry. For you and Christina. Yep. Got it. Good. Christina, you get it? Rylan, you got it. Yeah. Okay. So now back to our bikers. Okay. So Rylan says that biker A did the same work as biker B. Okay. Do you guys agree? So we're just talking work. Yeah. You guys agree with Rylan? Yeah. Okay. And Rylan also says that biker A had more power. Yeah, yeah, yeah. Yeah. Exactly right. Exactly right. You guys are good. So this is question number 4. Yeah. If they're going up the same hill, right? Same distance, same force to get up there, that is work, right? So the work is the same. It's just that biker A did it a lot more powerfully because it only took him 30 seconds. Perfect. Awesome. So let me know. You good? Thank you, Grace. Thank you, Pacifico. Thank you, Becky. Rylan, I know you got it. Thank you, Jenna. Christina, you good? Yeah. Party. Love it. Love it. Love it. Love it. Antoine, you good? Yeah. Adrian, you good? Angelica? Yeah. Perfect. Yay. Awesome. Okay. So, we can use this, right, to calculate which motor or car or whatever we have, and to determine which one is more powerful, right? So here is a practice problem, okay? I'm going to need somebody with a calculator to give me some answers here. So my problem says a 50 Newton rock, okay? Newtons, that means this is my force, okay? Needs to be lifted 2 meters. That's my distance. 4 seconds is time. Motor B, that's time, is in 8 seconds. So I need to calculate the power. But the problem with this is to calculate power, I have to know the work that's been put in, right? So I need to calculate the work required to lift this rock first. Both motor A and motor B, my work is 100 joules, okay? Both of them is 100 joules. The difference is how fast it's happening, okay? So 4 seconds for motor A, and I know that 100 divided by 4 is 25 watts. Notice this is a capital W, but it follows a number, so I know it's a unit, right? Now, 100 joules divided by 8 seconds. Somebody do that for me, okay? On your calculator, what is 100 divided by 8? 12.5. Thank you. 12.5 watts, okay? So notice, thank you, Becky, thank you, Kara, thank you, Pacifico. Notice motor A has a decreased time, right? Decreased time. Motor B has an increased time. The power increased for motor A and decreased for motor B. Are they directly or inversely related? If they go in opposite directions, if one goes up and the other goes down, is this directly related or is it indirectly related? What do you guys think? Inverse. So smart. Yeah, it's inverse. So with less time, the power increases, and with more time, it decreases. Yeah, so many answers. And I'm going to come over here so you have a chance at it. Okay. Yeah, this is 5, 6, 7, and 8. Yeah. And I know it's a lot. Awesome. Somebody's done. Brittany, thank you. Najina, was that you too? Yep. Perfect. Thank you. Thank you. Thank you, Grace. Thank you, Pacifico. Thank you, Julia. Awesome. Fabulous. Okay. Angelica, you good? Antoine, how about you? Darwin, DC, you guys good? Thank you, Errol. Emily L, Emily R, how's it going? Gata, you good? Thank you, Gwen. Thank you, Jennifer. Thank you, Maddie. Thank you, Gina and Pamela, Becky, Ryan, Sabrina, Tatiana, and Yosef. Awesome, awesome. Yay. Good, good, good. Okay. Anybody need me to wait? If you need me to wait, drop it in the chat. Okay. Drop it in the chat if you need me to give you a little bit more time. Okay, I think we're good. So that's a lot. 5, 6, 7, and 8. We can also use this formula to calculate how long something happens. Okay, so here is an example. Okay, I'm pushing a car up a hill and I have 200 joules of work. Okay, and I'm putting out 2.5 watts of energy. So how long is that going to take me to go up the hill? This is my formula for work. And if I solve for T instead of power, I would get work, which is 200 joules, over or divided by the power. Okay, so 2.5 watts. Somebody with a calculator, tell me what is 200 divided by 2.5? How many seconds? 80. Yeah, that's going to take me 80 seconds to push the car up the hill. About what, a minute, 20 seconds. Okay. Probably it's not a very tall hill. Whoops, so sorry. Okay, so 80 seconds. I want you guys to take a picture of this. This is an example that is very similar to question number 7 on your test. Question 7 on your test. Okay. So just take a quick screenshot. Okay. Perfect. Awesome. Okay. So when we talk about power in the United States, we don't always talk about watts. Sometimes we talk about horsepower. And all of you that are into cars, okay, I have a short little video to show you and how horsepower and watts are related. Okay. Okay. So easy peasy lemon conversion. Okay. If we look at 2 cars, a Dodge Challenger that has 305 horsepower, right? Is going to have it with the same destination as a Chevy Camaro that has a 275 horsepower. with the same destination, the Dodge Challenger has the ability to get there faster than the Camaro because it has more horsepower. Okay. And we can do these conversions knowing this conversion factor right here. Okay. So here are examples. Okay. We are going to calculate how many watts this Dodge Challenger actually has compared to the Chevy. Okay. So all I do, okay, is take the Dodge's horsepower and multiply it by 745.7. And then I am going to also, for the Chevy, I'm going to take 275 horsepower and multiply it by 475.7, and we'll get the watts for each car. So somebody tell me, what is the watts for the Dodge? Okay, and then somebody else calculate the watts for the Chevy Camaro for me. Okay. So 227,438.5 watts for the Dodge. Okay. And then for the Chevy, how many watts is the Chevy? 275 times 745.7. I think this is one something. Where are my calculator people? Thank you, Jennifer. 1,082,695.5. Okay. So just like what we would expect, the car with the higher horsepower has more watts than the car with the fewer horsepower, right? So what I want you to do is go ahead, take a screenshot of this. This is another example of a problem that you need to do on your exam. This is question number 6. Not the same numbers, but similar. Okay. So go ahead and take a screenshot. Give you 20 seconds or so to do that. Okay. Awesome. Thank you, guys. You rock. Okay. So now that brings us to this problem. Okay. This problem says a car's engine applies 1,168 newtons to make the car move 25 meters in 0.4 seconds. We have to calculate the work done by the on the car by the engine, and then we have to calculate the engine's power. So we have to calculate 2 different things here. Okay. If I take my givens that are in the problem, okay, I know that newtons are a force. Okay. Sabrina, you're correct. Okay. 25 meters is distance and 0.4 seconds is time. I would have all those filled in. And then the answer from number 9 is going to go into the problem for question number 10. Okay. So I want you guys to do questions 9, 10, and 11 on your own. Drop it in a private chat with me. Rylan, yes. Becky, yes. Okay. Pacifico. Yep. Jalea. Yep. Okay. Remember in number 10, you are dividing, right? In question 9, you are multiplying. Pacifico. Yes. Okay. Becky. Yes. Rylan. Yep. Okay. Drop it in the chat box and I will tell you if you are right or wrong. Jalea, no, you're dividing, right? Jennifer, yes. Grace, oh, gotcha. Yeah, thank you. And Grace, on that one, tell me which question you were looking at. Jennifer, you're going to multiply 1,168 times 25. And then the answer that you get from that, you'll divide by 0.4. Jalea, yes. Yosef, yes. Grace. So Grace, I want you to just multiply 1,168 times 25. Okay. Pamela, yes. Yosef, that's 10, yes? Yeah. Yes, Jalea. Yes. Gotta. Gwen, yes. Grace, yes. Jennifer, yeah. Becky, yes. Yep. Rylan, yep. Kara, yes. That's for number 9, right? Yeah, and then use that answer in question number 10. Awesome. Okay, guys, when you are finished with these 3 questions, you are done and you are free to go. Okay? I hope you have a fabulous, fabulous day. Bye, Rylan. Bye, Ryan. Bye, Becky. Bye, Maddie. Okay? If you still want help, hang out. Bye, Brittany. Bye, Jalea. Bye, Najina. Bye, Pacifico. Sabrina. Have a great day. Okay, Grace. I know to increase, Joseph, you're correct. I know, Gwen, yes. Pamela, yes. Bye, Joseph. So Grace, I know to increase power, I need to decrease time. Okay. Bye, Pamela. Bye, DC. Because they're inversely related, right? So if I want to increase power, I decrease time.